Recording is underway. So whoever's going to share the slides, you want to quickly test that and make sure you can share the screen out. While they're getting that set up, just a quick welcome everybody. This is the first technical-oriented session for our systems-facing track. We're going to cover Ceph as a campus storage solution today, and we have Steve Anthony as well as Kyle Hutson. They're both HPC admins. Steve is at Lehigh University and Kyle is at Kansas State. So we'll turn it over to them as soon as they get their slides shared out. Oh, and then as noted with the recording, if you want to ask a question but don't want your name associated with the question, feel free to send a direct message to either myself or to Alan Silver, and we can ask it in a general fashion on your behalf.
Can people see my screen now?
Yep.
Okay, good. Yay. Now can I tell this thing how to go there? There we go. Say technology is fantastic when it works. When it's not, it's a real pain in the rear. Okay. So this is actually a slide deck that I put together for SC last year. I gave a talk at a booth there. And so I've invited Steve to join me on this. So most of the stuff has the Kansas State logos on there. That don't put a whole lot of stock in that. That's what I put together. Steve's helped out with quite a bit of this too. So,
hey Kyle, right now we just see your Slack window.
My Slack window. Get the wrong one. Great. Let's see if I can put this. All right. Let's move this here and go present. See if that does it.
Yep, that's working.
All right. Okay. So first of all, some basics. And Steve, feel free to chime in anytime. And as far as that goes, I am not one of those stand up and I'm the lecturer, you're the student, and you shall be quiet kind of things. If you have questions, feel free. Steve, you agree with that?
Yeah, that's fine with me. I'm happy to have people jump in anytime, stop us.
Okay, good. So Ceph, the name comes from cephalopod, which is octopus, and it's really supposed to be very parallel in nature. At its core, Ceph it's an object store completely underneath everything else. It's meant to be very highly redundant, very highly parallel, and created to avoid single points of failure. We put other things on top of that object store, but that's really the basics of it is in an object store, kind of like S3 or something like that. To really understand Ceph, there are some concepts that you're going to have to understand. And the first one is called crush. And I had to look this up, controlled replication under scalable hashing, because everybody just calls it crush. That is the system that Ceph uses to make sure that it has enough copies of things. You give it a policy for every object that you put in there, how it's broken up into pieces, how many times it's replicated, how many copies you need to have to keep going. And the other piece of that is RADOS, which again, I had to look up reliable. A lot of you can read it there. Part of my screen's covered up by Zoom anyway. RADOS is the piece of this that trying to think of a good. Steve, help me out here.
Yeah, so it sort of it sort of manages the objects and then looks at the replication and looks at do the objects exist? Do you have enough copies? And if you don't, starts remaking copies, redistributing copies, lays them out across the various disks in your cluster, so that when you store files there, they're distributed across the cluster. You don't have hot spots and cold spots, and then allows you to access them and find objects from the host using those calculations, so that you don't have a single metadata server that has to pull, that every client has to pull for the object locations.
Right. So the core idea behind this being that every client that talks to the server, it can compute for itself where that data needs to go to. So if you have, like in our case, we have 28 servers. You don't need to ask one particular machine, hey, where's my data at? The client itself can compute that and talk directly to the server where the data is going to be stored. And if you're like me, I'm a big fan of free open source software. So there is paid support available, but when you start looking at some of these other distributed data stores, you can start writing checks with big zeros on the end. And I have nothing against writing checks with big zeros on the end if I have it available, but I don't. I don't know about your institutions, but
it's always easier
very
to
cache constrained.
Yeah, always easier to set up a proof of concept when the first step isn't a licensing fee.
Exactly. But there is paid support available. Inktank is a part now of Red Hat.
Yep.
And that provides paid support for Ceph. So it actually does have a development team. It was created by a guy the Crush was part of a Sage Wiles doctoral thesis, and figured out that he could actually make money off of it, and it actually is self-supporting, which is always a good thing for an open source project, in my opinion.
And I think that was around 2007, so it's been around for a while.
So here, this is stolen blatantly from Ceph's website, so this is not anything I made or anything like this. But you can see RADOS at the bottom, the self-healing, self-managing storage nodes that can be talked to through the library, librados, or from the Ceph file system, which we are using. Are you using that too, Steve?
Yeah, we just started using CephFS for our Scratch file system.
Okay, we have been using CephFS since before it was marked as stable. So we were kind of on the bleeding edge of this. We've gotten emails from SageWile himself saying, hey, you found a bug in our thing. Sorry, your file system was down for several weeks there. So there's been some pain points with that, but even knowing all that, I still would probably have done it again. It's been very good to us. There's also the RADOS gateway, which you can use like a S3 or a Swift type of interface to it, so just as a straight object store. And the other thing we use is RBD, which is the RADOS block device, which lets you set up like a hard drive. In our case, we're using it for virtual machines.
We use RBD pretty extensively, mostly mapping on NFS or Samba servers and then resharing the image that way. So you get a block device on your host, and then we share it out. And that was a bigger issue earlier on. There were some points where Ceph versions changed, and you needed a specific kernel version to access that data. And in Cent, at that point, I think it was Cent 6, you couldn't get the kernel version new enough to use those features. So resharing it was the only way to provide Ceph storage to those clients.
So you've been using this quite a while too, then?
Yeah, I think we started in 2013, 2012.
I think that was about 2013, 2014, somewhere in there is where we started. So there's been some bleeding along the way, but it hadn't been bad. So what? Why do you care? The biggest issue with Ceph that I really like about it is what failure domains. You can set a failure domain is what can you afford to lose and still not lose any of your data. So if you've got one machine with 5 disks on it, you'll probably want to set your failure domain to be a disk, because you can lose a disk and then everything will reheal itself. It'll distribute that data back out on there. As you get bigger, you might set it up to be a server. One server will go out and the rest of it will again take over and re-replicate everything. As you get bigger, you can make that, data center, row, rack,
continent,
city, planet. If we get to that point, we're not there yet, but it could happen. It's really meant to scale all the way up and out.
Quick question about that, actually.
Everything in there is redundant. You get to choose how redundant you want to make it.
Kyle, I think we have a question.
Okay.
Yeah, regarding the failure domains, I've been looking at stuff for a while. I have a cluster here as well. I'm currently using erasure coding and host-based failure domains, and I was wondering if I could increase my number of erasure blocks basically, and have it fail back. Like if I could set it to OSD for the failure domain, but have it be smart enough that it tries to still spread it out amongst hosts. I haven't seen anything about doing that sort of a configuration.
I think it will still spread it across. Actually, you know what? I don't know if it will spread it across hosts then. That's a good question. I'm not sure. We haven't really done much with erasure coding, mostly because our original hardware didn't have enough resources to do the computations. But
yeah, we are using erasure coding, and that should do that. Yes, if you have your failure domain set to a host, it'll spread those pieces of the erasure coded pool across that, which everybody else is probably confused about what erasure coding is. You can think of it as kind of RAID across systems, so that it'll put a piece of data there and a piece of data on this machine and a piece of data over here and a piece of data over there and some parity bits, so that it will all, so again, you can lose pieces of it without losing everything. That answer your question at least enough for now?
Yeah, that'll be good for now.
Okay. Moving on with Ceph itself. It does use the same storage for block devices and for your POSIX file system. If you're using that CephFS and you're using RBD and all those kinds of things, it's using the same storage underneath. The nice part about that is that as you add, you don't need to add to a particular spot. So as you're,
I mean, unless you really want to, you can carve up a pool and say these specific hard drives are only available for this storage pool, and then this storage pool provides RBD access for these clients. And this other storage pool is composed of these hard drives, and that provides CephFS to these clients. But that typically would only happen if you had different classes of storage. So if you had SSDs or NVMe, you would want to group those together to provide a faster experience. Or if you had OpenStack in front of part of it, and you wanted to make sure your VMs were isolated from latency from your HPC resources, for instance. So you could have a researcher crush the cluster and then take down all your VMs.
But by default, yes, you're right, and we actually do some of that too. But
by default, everything
is one big.
You'll get one pool,
and as you add storage, you can decide where you want to put that too. Talked about failure domains. I put this as the default hierarchy, and I said I think because we've modified ours. So
that looks right to me.
that was what I seem to remember and what I think I found. So OSD, that's the base level that you can think of. OSD stands for Object Storage Device. That typically is a disk. It can be a partition on a disk, but typically it's a disk. Host chassis. We have one of our two clusters that we have. I'll be talking about that a little bit later. That instead of being so you think of typically hosts being within a chassis. Well, we have several hard drives that are the old IBM DS series. So we have several chassis holding OSDs with a few hosts on the outside. So we've actually switched that around on ours. Again, racks, rows, PDUs, however you want to move this around, you can add more in between here. You can edit these, and it's kind of cool that you can set this up this way.
You don't have to, though.
Right. The default is I believe OSD is your failure domain, correct? Is that right? Or is it
I think it might be host.
I think it's host unless you tell. Yeah, I think you're right.
I think it might be host by default.
Yeah. So, but yeah, you can set up your failure domains, and these are the types and the kind of the hierarchy that it comes with. Like I said, if I'm not mistaken. Again, this is kind of talking about what I just said. You can add those add them at any level. You can make up your own, and you get to choose your failure domain. If you want, it has a default built in, but you can choose your own failure domain. So if you have a larger failure domain, your performance is slower because you're going across more area. Your latency is always going to be bigger, when you're going across space and that kind of thing. But it is going to be more resilient. So we have actually considered, we haven't done, but we have considered getting together with other universities in our state and setting up a statewide Ceph cluster for research data, where everybody gets a piece on each campus, and it would be slow, but it'd be very resilient because everybody, you could wipe out a whole entire town and the Ceph cluster would still perform. Our redundancy, this is by default, it sets the replication to 3 with a minimum of 2. What that means is that as you put data into it, it makes 3 copies of it. And once it has 2 copies made, it says, okay, you can move on from there. So it doesn't tell you that it's got it done until it's written 2 copies, and then in the background it'll make a 3rd copy.
Which is why it's slow when you increase the failure domain, because it has to write those copies out to your other locations.
Exactly. If you go below that minimum, you can read, but you can't write to your pools. Again, if you have fewer replications, that means it's faster. So something like Scratch, where it's not as critical. If it goes away, it goes away. You might want fewer replications. So matter of fact, we do that on our Scratch pool. We have a replication of 2 with a minimum of 1. So that gives a faster write, but less resiliency. More replications, obviously it's going to be slower to write, but more resilient. So you get to choose what you want on there. Erasure coding, we kind of got into the weeds on that a little bit ago. Erasure coding, I think it was like RAID on steroids. It's multiple machines as opposed to being on a RAID being on a particular one bit of hardware. So we've spread out these disks, instead of 10, 12 disks per RAID device, we've got 580, I believe, right now in our Ceph cluster. Performance, it does slow down with erasure coding, but you get to save on space. So for instance, on what we have right now, we have the homes volume, which is where most people save most of their stuff. We have a quota of 1 terabyte per user on that to keep them from filling all that space up. Our home volume has the default, the replication of 3 minus the minimum of 2. We also have a bulk storage space where people are saving genomes and large quantities of data, where that is erasure coded. So it takes basically half the space, because instead of being a replication of 3, it becomes basically like a 1.5. We have breaks that data up into 6 chunks with 3 parity bits is the way we have ours set up. So so for every terabyte you write, it's taking up 1.5 terabytes on disk for the erasure coded pool. So
there is or was a performance issue with that, where it couldn't do partial updates of objects.
Right.
I don't know
and
if
that's
still...
the whole thing, is that you especially when it gets to being appending, things like that, it has to read and write everything again. So that's why it's become slower as you start using erasure coding. But again, it's a matter of what you want, whether the speed is important to you or the space is important to you. And they've just changed this. It used to be that any erasure coded pool had to have a cache tier if you're using it for the Ceph file system. I think they've done away with that now. We're still using ours, although we've talked about moving off of it. cache tiers have been probably 90% of the problems that we've had with.
Yeah, we had a lot of issues with those too when we did some erasure coding.
The cache tier will work great for quite a long time, and then it will suddenly forget how to flush itself, and you have to go and manually flush it, and nobody seems to have figured out why. How to scale up features there. One thing they have gotten going now is active metadata. So that's always been kind of the Achilles heel of any big file system is the metadata. So now you can have multiple active metadata servers that update each other. As we talked about earlier, Crush, the clients talk directly to the hosting server. So if you add more servers, you add more bandwidth. So, you know, we have ours on a 40 gigabit Ethernet, and actually a few of them are on 100 gigabit Ethernet backbones. As we add more disk space, we're also adding bandwidth. So clients are talking directly to those disks and not being filtered through some, you know, the smallest pipe through there.
Yeah, our cluster network is 10 gig on the front, the public and private side, and we don't see anything near that because you can saturate a client at 10 gigabit, but that one client request gets broken up over 7 or 8 or 10 hosts, and so that each individual Ceph host doesn't see as much bandwidth as a single client produces.
And as we talked about failure domains, as things break, it automatically heals itself. That's the coolest part about this. You know, like I said, we have somewhere about I lost my train of thought because I just noticed a message from my boss in in our Zoom channel. Sorry.
A lot of things can go wrong, but it tries really hard to heal itself.
It does, and
it does
like I say, so as you know, when you got like we have like 500 some odd disks, failures happen.
Yeah. So
you know the fact that a disk goes bad, it marks it as bad, and then those replications that were on that on that disk, they get automatically sent elsewhere. If you're erasure coded, those parity bits they get moved elsewhere. It all self heals, and it's pretty darn slick. Question in the chat is, what are your typical bandwidth numbers, especially for 10 gig and 100 gig connected clients? I will speak for myself with our, we see, like I said, a single client can't really saturate that line itself. It just can't push that amount of data through there. We do see typically somewhere in our 40 gig network is what our typical Ceph node is connected to, and it is not unusual for it to push maybe 10 gig if everybody's working real hard. The time that you really see it is when it does that rebalance.
Yeah.
We can look at our network graphs, and I can see when a disk has failed because you'll see this big shark fin of we got a huge amount of data that's going up here, and then it starts to heal itself, and it slows back down, slows back down, slows back down. So
yeah, it's
ganglia for our network graphs, and you can see those pretty obvious, and it'll pretty much saturate the pipe when it does that.
Ceph lets you just assign a network for public users and a network for replication and recovery. So you can build a faster replication and recovery network because that's where you're going to see most of your bandwidth, and a slower client network, and then just add more Ceph clients. You don't need to add necessarily 10 gig on public and private or 100 gig on public and private.
In our case, we don't have a dedicated RDMA network for like Luster that most people have for high speed. So in our case, we wanted to push as fast as Ethernet as possible out there. So that's why we opted for the faster Ethernet on ours.
Yeah, on our old cluster, we would see the reshare host pushing 4 to 6 gigabit easily. On the new one, it's still not 100% in service, but it's trivial in our testing for a single client to saturate 10 gig.
Okay. Somebody in the chat said that with a 40 gig network, 6 storage servers, he's gotten the bandwidth in Ceph at 6,800 megabytes per second, using around 10 clients at 40 gig. Erasure coding 7,200 RPM disks. The question is, do you use hardware RAID on OSD hosts? you don't want to use RAID on there. It wants to talk to a disk rather than to a big bunch of disks. Now, that being said, I found we have gotten performance improvement by creating, instead of just a JBOD, taking our RAID controller and making it a RAID 0, 1 disk RAID, because that uses the caching from the RAID controller. So that's given us a performance boost. But you don't want to rely on that hardware RAID, generally speaking. That get you, Dimitri? Good.
Yeah, we don't use the hardware RAID either, except for OS disks.
Right, OS disks is a different deal, yeah. Performance, how they get faster stuff. BlueStore is something fairly new. We have just, a few months ago, completed moving all of our disk over to BlueStore. Before BlueStore, which I know I'm kind of defining it by itself here, so it's kind of confusing. Before BlueStore, traditional disks has what you would actually set up a disk and put a file system on it. So for instance, XFS was by the default. So you would have a disk, you would put a partition on it, you would put in that partition, you would format it as XFS, and then you would point Ceph to that XFS disk. BlueStore is taking and talking directly to the disk itself. So it's instead of being it's a straight file system directly on the actual disk, as opposed to being on a partition on another sort of file system.
We have another question.
Okay.
Do you have any opinion on number of OSDs to a host, size of an OSD, and memory per OSD or per host?
There is, if you Google PG Calc, all one word, it'll take you straight to the Ceph page where they have you figure that out.
Great.
So
I think
that is, no, OSDs to a host.
No, OSDs to a host, size, but OSD.
Sorry,
yeah.
OSDs to a host. We have 16 on most of ours, and that works pretty good. We also have some like 90 bay JBOD kind of drives with like 50 in there. That's really too much. The problem is not really so much the number of OSDs to a host. It's really how much RAM you can cram at it.
It's also relative to the size of your cluster, because and what your failure domain is. So if your failure domain is a host and you lose a host and your hosts have 30 disks in them, you have 3 hosts, that's a problem. You've lost a third of your cluster in one shot. But if your cluster is 30 hosts and you have 16 or 20 disks in a host, that's not as big a deal.
Good point. The recommendation has stayed pretty constant, and that is that you want to have 1 gig of RAM for every terabyte of data on your server. So if you get to a whole bunch of disks, you're going to quickly find you can't shove enough RAM in the box to make that happen. And it's almost misleading, because as you're watching RAM usage under normal circumstances, it seems to be much lower than that. Mm-hmm. However, if something goes wrong and you lose a disk or a host or whatever, that will get eaten quickly, and that's when it'll really bite you in the rear. So that's why I say you want to make sure you keep that.
Especially with erasure coding. Especially with erasure coding. Because I've noticed that when we went into erasure coding a little bit, our hosts would use far more RAM when there was a failure than they did when it was just a straight replica.
That makes sense. And somebody did post the PG Calc, ceph.com/PG Calc. I know it was pretty easy one there. It does allow you, now this is kind of getting into some advanced usage here, so this is not anything by default, but you can choose to use SSDs or NVMEs for particular things. So like you can use your scratch pool to be using SSDs or NVMEs and leave your slower erasure coded stuff on spinning disks. Or the one thing I will always recommend is put your metadata pool on as fast of a disk as you can get. You're going to want to put a lot of IOPS through your metadata server, your metadata pool, if you're using CephFS.
Mm-hmm.
Go ahead.
It may also be worth noting that at least when we moved to BlueStore, we noticed about a 2x increase in performance on our cluster.
We noticed a gain, like I said, we were using RAID zeros, a whole bunch of RAID zeros.
Mm-hmm.
And so we saw an improvement. I would say it's probably more like 1 1/3 to 1.5 times speed up. So
we also happen
data
to be
points for everybody there.
losing all of our journals at the same time. So it was very convenient for BlueStore to be released.
Yeah. So yeah, if you're looking at how to effectively use SSDs and or NVMEs, first thing I'd say is go with your metadata storage, and beyond that, your write-ahead logs, if you're using BlueStore, or your journals if you're using traditional. That will speed things up about as much as anything else as you got there. I've already mentioned that you can use caching, but personally, I would not use caching if you could get away from it because of the gotchas there. Inline data, that's an experimental feature they've got right now. So if you've got a tiny, tiny file, it'll store all that within the metadata and not actually have to put it out on the disks.
Right, because the default object size for Ceph is 4 megabytes. So if you write a 2K file, it writes a 4 megabyte object.
Right. So it ends up doing lots of writing there. It doesn't really need to be doing.
Yeah.
And metadata load balancing, again, that's experimental. It's also called Mantle, so that's why it's in quotes there. That's that is their name for the metadata load balancing is Mantle, and that is an experimental performance enhancer that they have. Again, not ready for prime time yet, but I'm sure we'll be giving it a try when they mark it as stable. This is my current Ceph deployment. We have 2 clusters. The first one is in the building that I'm in right now. We have just a little over 3 petabytes raw, 28 servers, 5 monitors. Monitors are what keep the quorum and make sure everything's talking to each other and keeps everything happy. We have 2 metadata servers. The pools we have, home, which are, I mentioned earlier, replicated 3 with a minimum of 2. Scratch, which is a replication of 2 with a minimum of 1. Bulk, which is erasure coded. And Ganeti, which is not using CephFS, that's using the standard replication pool, but that's what we use for our block devices. Ganeti is a virtual machine orchestrator for QEMU KVM, if you're not familiar with it, put out by Oregon State. So that is the one I work on pretty much all the time. Significant amount of data, and we use this all the time. So that we put it through its paces a lot. The other one, our second cluster, is in a different building. It's where we used to be housed. And we have 600 terabytes raw there, but only on 2 servers. That's running a big IBM DS series. So we have, I think, 8 or 9 chassis on each one of those servers. And we only using those for archiving for backups. Somebody asked about hardware, what we have on there. Of our 28 servers, 26 are Dell XD 730s with 16 drives apiece in them. The first 24 of those have a combination of 6 and 4 terabyte drives because that's what we get at the time. The newest 2 have 8 terabyte drives because that's what we get at the time. The last 2 of our 28 servers are ginormous JBODs that we have 50 disks in. The reason that we did that those don't have any sort of SSDs. Those are basically, we're just using those for bulk and for backup. So by going in and tweaking what Ceph does, we can tell it, like on our replicated pool, make the first copy, make the first 2 copies on the Dell boxes, because those we have some NVMEs in there that'll just help speed up the writes by having those write-ahead logs on them. But the big boxes we do not. So those are always the backup copies of the last ones to be written. They're also not primary, so that means any reads come from the Dell boxes instead of the big JBODs also.
You have a question.
Yes.
What drove the decision to have more than 3 monitor nodes?
The decision to have more than 3 monitor nodes is because we have multiple racks of this, and we didn't want a PDU to kill the whole thing. Really want to try to shut down the monitors last. So we actually tried doing like everyone on a monitor node, and that turned out to be a bad plan. So we scaled it back. So we have 3 in one rack and 2 in another rack. Thoughts on Colake? Okay, answered it. Yay! Being ahead of the game. The older cluster 2, those are sitting on some older servers also. Like I said, we didn't care a darn thing about performance on that. So we're slightly under the 1 gig per terabyte, and we have a whole lot of just raw space that was sitting out there being unused, unmanaged. So we're just trying to make as good use of it as we can. We were not looking at performance or anything on those servers. Okay, cluster number 1, 2 metadata servers, that's active. Yes, it is now. We've gone back and forth. We've had some problems early on with active, and we are back to using active, and it seems to be working pretty well right now. Next question, what are you using to serve out home, Scratch, et cetera? Example, CephFS. Yes, we are using CephFS on all our nodes. And kernel modules, yes. We have not used Fuse for anything at this point.
Yeah, all of our CephFS shares are kernel mod on the client.
When Ceph was pretty new to the game, that was a bigger deal because it was hard to get it. Like say in CentOS, you couldn't get the kernel client. Now that's all built in and it's a piece of cake and we just do it. It's not a big deal.
We still do NFS and Samba with our RBD images. So that was originally Pacemaker and CoreSync, and we had a lot of problems with that. So we ended up going back down to just one NFS host and a script that will map and mount everything on the other one in the event of a problem. Typically that hasn't happened. We had many fewer problems once we moved to a single point of failure than when we had a redundant cluster for that. Ideally, when we'll be able to move the rest of that to CephFS and just get rid of all of that together. We have done a little bit with NFS Ganesha, but not a ton. We had one user who would occasionally crash some of the NFS threads, and we thought by moving that to user space, we'd be able to restart those. Turns out that didn't work so well. Ganesha was still refused to restart those, and we ended up having to reboot the system anyway.
Okay. I see the next question I have is a loaded question. Because what does your boss think of Ceph? That question was posed by my boss. So he actually has it's really sexy. It works really great most of the time. And then all of a sudden it'll bite you. Question there. So no CephFS quotas in use given the use of kernel client. No, we do not actually use CephFS quotas. We tell people there's a quota, and when they go over it, we contact them directly and gripe at them. So that's how we get around their quotas.
Yeah, and ours is on Scratch right now, so there's no expectation that it's going to be there tomorrow. And there's a script that will remove. So users can only write to a directory that's created for their job, and that directory exists for 7 days. And then there's a script that will remove those directories based on when the job was completed.
Okay. Next was how much time and how many people manage your CephFS setup? That's a good question. We have 2 sysadmins here. Probably spend more time on storage than anything else. However, it's very cyclical. You know, there might be times that we got both of us working on it for a week, and then now it's, you know, maybe a quarter of an FTE on a weekly basis.
Yeah, for me,
that's a finger in the air guess as to where it is.
For us, it's just me. There are 2 other people who are tangentially involved and can do things like create images or would be qualified to poke at it if there were a problem. But I would say that again, when it's working, it's fine. It occasionally you'll spend a couple days or a week scratching your head trying to figure out why the cluster has marked a couple of your objects as unhealthy and you can't heal them. And it turns out that you create a snapshot when the cluster was already unhealthy and it thought it removed those snapshots, but actually didn't. So when it goes to scrub, it finds them and tells you that they exist, and then you can't remove them.
Next question is, how are upgrades? What was the base version you started with, and what have you upgraded to? We actually started ours clear back at Bobtail, I'm pretty sure. That they go in alphabetical order. So Bobtail would be version 2, and they just released Nautilus. So version 14, did I do my math right there? We've gone through a whole bunch in the middle. There was one kind of painful upgrade in the middle. If I remember right, it was moving to Joule. They changed some things in there that caused some issues. But other than that, I generally wait and look at the mailing list and don't deploy one for about a week on a major rev, and make sure that nobody else has issues. And like I said, we've been the guinea pig a couple times when we were at certain points, but their releases tend to be pretty good.
We hadn't had any problems upgrading. For instance, when you do the upgrade, it won't apply it until you restart the instances. So you have to apply it and then restart your monitors, restart your metadata servers, and then restart each of the OSDs to complete.
That's the thing. I would also make sure you look at the upgrade notes, the release notes, because they will tell you what order you want them to do in.
And those recently have been getting a little sketchy. So the past 1 or 2 point releases for the Luminous series, the packages showed up before the release notes, and then there was a bug, and they said don't install it. So wait for the release notes before you do the updates.
Somebody agreeing upgrades are fairly painless. Don't upgrade to this version from that version. They'll say that's a good thing to see in the release notes. Yes. Next one, what are your typical Ceph clients, VMs, OpenStack, any HPC? Mine is almost all HPC. We have a 350 node plus HPC environment, and that's what we are using the CephFS on. We're using VMs also, but that's pretty much what we're dealing with. And when I say scratch, how's performance on large reads and writes? Actually have some, wait for our slides on that, Vikram, because I have some performance numbers in there.
Yeah, our clients are mostly HPC, but the first cluster that we deployed was a general campus resource, about as much as it was an HPC resource. So every faculty member at the institution is granted a terabyte of disk space that's served out via Samba.
Okay, let you talk about yours here.
Yeah, so we have I guess 3 clusters now, but they're really 2 because the 2013 cluster was split into 2 sites so that we could do backups. The production cluster is now 700 terabytes raw on 7 servers, and we do serve everything Samba, NFS, iSCSI, and CephFS. I would love to move everything to CephFS after having used it just a little bit. It's so much nicer to deal with than having to map an RVD image and then reshare it via NFS or one of those other protocols, just because you have a situation where that client or a client causes a problem, or that server crashes, or you need to do updates and you have to schedule downtime, and that's not something that people really enjoy having. So it has been a big bump over our first cluster. So our first cluster was basically built to be as cheap as possible, just to get people out of their small, medium business NAS devices, consumer NAS devices, onto their desks and into some sort of central resource. And we really under-provisioned that. I think if you go to the next slide, I believe we have the stats on that, and that only had 16 gigabytes for I think 13 OSDs, and it hadn't been a problem, but occasionally there'd be a rebuild and it would be an issue, or something would be saturated. The biggest problem was the SSDs for that cluster, mostly because they were built to be as cheap as possible, and that was great until people started using it, and then they would start failing. And at that point, they were a journal, so you'd lose every OSD behind the journal. So every time you lost the SSD, you'd lose 5 OSDs, and then you'd have to replace the journal and reattach it and do a lot of touching to get it back in service.
We ran into some of that same issues. The Dell 730 XDs that we have came with quote unquote read optimized SSDs, and when we started pushing them hard, they pretty much fell over. So we ended up having to replace those. And so we actually have NVMEs in ours now. So we're still using those same slow ones just to boot the OS, but we're using NVMEs for anything that we're data-wise on there.
It's not as much of an issue now because with Blue Store, you're writing directly to the disk. There's not necessarily a journal anymore. But at that point, every write hit one of those disks. And so you really need to look at what the total your estimated lifetime writes for those drives that you're deploying are before you get into them. Like I said earlier, Blue Store came at the perfect time for us because we were losing those disks left and right, and they were now out of warranty. And so it became a race to upgrade the cluster to Blue Store before we lost too many journals, which we managed to win so far. So that's been helpful. The new cluster on the next slide, it was vastly faster than the previous cluster. We went from 8 cores to 16 cores and from 16 gigs of RAM per host to 128. We had purchased it in the transition to Blue Store before it was really a thing, so we purchased it assuming that we would be running file store. Those SSDs now form the pool for the Scratch ZFS file system, and then the 8 terabyte drives are RBD for our legacy images.
Before I do this, question popped up. What's a typical ratio of number of servers in Ceph cluster versus number of Ceph clients? I don't think it's so much a matter of ratio of servers to clients as it is how much data you're pushing on there. Do you agree with that?
Yeah, I would say, the only reason you would add more servers because you had more clients is because you needed more bandwidth. And adding more servers will get you more bandwidth. So the more servers, you can get away with slower hardware if you have more of it, because Ceph will scale that out. So I don't think I don't know that we don't really track number of clients versus number of servers.
Okay, good. Pros and cons, and I will tell you, anybody that tells you there's no cons to anything is a salesman. Don't listen to them. So this is my pros and cons for Ceph. First, active development. They are working on this all the time. They are constantly making performance upgrades, feature upgrades. They're going great guns on this. It's kind of impressive the pace they've managed to keep for this project and keep it up for the long period of time that they have. It works pretty well for most typical situations. They say if you need a super low latency kind of thing, you're probably going to want to go with something over RDMA, InfiniBand Luster type setup, something like that, or GPFS, some paid setup there. But for most typical situations, it works pretty well, and the performance is good enough. Cost, obviously, you're paying for hardware, and that's it. There's no software on it unless you want to pay for it. And if you do, there is support available. So the redundancy is better than most parallel file systems that we've seen. It's much better, maybe a bit of a stretch. It's better. The simple fact that the default is for 3 copies is a lot better than most, because it does what I'm trying to say, most of them are doing some sort of erasure coding back behind the scenes anyway. Next question is how much per petabyte? I think we paid, and this was 3 or 4, it's been over 3 years ago, because our stuff's out of warranty now. Our first buy is out of warranty. And that costs $300,000 for a little over 2 petabytes, just touch over 2 petabytes.
Yeah, that sounds about right. I think ours was 70-ish thousand for 700 terabytes.
Question, do you use paid support? I have never had paid support. I have gotten support through the mailing list, but not any paid support.
We actually did pay for support way back in 2012, 2013, when they were still Inktank, before they had been purchased by Red Hat, to have a consultant from them come out and help us set it up. That was fantastic. We went through 2 days with that person who was, was definitely an expert, knew what they were talking about, helped us get the cluster up and running right away. but we haven't paid for support since then.
Cons. If you want to use the POSIX file system, it does require the kernel client, which was a bigger deal back in CentOS 6. Now that 7's got it built in, it's less of a big deal. When we were first starting to use it, that was an issue. Experimental features, like I say, they can bite you. We've run into that, and they still are bugs. Like our whole cluster was down for a couple months at one point while they were figuring out things. Performance maybe isn't as fast as some of the super fast ones, and it's only over Ethernet. So if you're needing that RDMA, they said they put that on there. Yeah, we'd like to do that someday, but it's not on their short-term list. So
it's been on the list for a long time.
It's been on the list for a long time. Deployment tools are dumb. When you first set up your cluster, you can use the Ceph deploy tool. After that, do it yourself. Their Ceph deploy is not a good tool in my opinion. I've heard they're reworking that too, but I have had nothing but trouble with their deployment, their Ceph deploy tool. Anything to add on that, Steve?
Yeah, we still use Ceph deploy just to replace disks or re-add disks. For the most part, it's pretty okay, as long as you're not trying to do anything fancy. If you follow the defaults and want to add one disk and do nothing else, it's okay, but otherwise, not great.
I think when I first set mine up, I had to set up an Ubuntu server because it wouldn't even run on anything else. So
yeah,
I know they've changed some of that since then, but I've still not had any very good luck even since then.
Well, even I think now their latest release won't build in Debian because they used a version of libc that doesn't exist in Debian. So
what I have found works well is we can take you run Ceph deploy and look at its logs to see what it was trying to do and then fix that. A lot of times it'll work. It's just like, oh, you made this assumption that was wrong. So it's not worthless from that point of view, but it's certainly not as robust as I had hoped that it would be. Okay, here's my numbers. I did some tests. I set up, now I will be the first to tell you not a fair test. Because we've had Ceph for a long time and we've got it pretty well optimized. We took a box and we put on everything else here that's not Ceph. I don't know if you can you see my marker on my screen here? Oh, that was the wrong one. The Homes, Bulk, and Scratch are our three ones from Ceph. Everything else here was with a single box. So we're comparing single box performance to multiple box performance. I'll be the first to tell you that's not really a fair test, but it's what I could get, what I could benchmark. So it's what I'm working with. This first one is, the blue line is output, the red line is input, and the green line is input, and the red line is rewrite. And you can see that Ceph is for the most part, it did really well on output. Didn't do as good on the inputs, but it kept right up there with pretty much everything else. I don't have this here with me, but just last week, I have a coworker that ran some benchmark tests. He didn't even know I was giving this with comparing our file system to that on Bridges, and the latency was not as good, but the bandwidth was actually higher on our system than it was on Bridges, which is I would certainly think would be a pretty optimized Lustre system. And you put that in there. Is that
the ranges from our tests?
Ranges from your tests. So yeah. Your input was a little faster, and your write
depending on whether it was RBD or CephFS.
Okay.
And CephFS being faster makes sense because it was on SSD, not spinning disk.
This one is latency, and I had to cap it because there were some really high latencies which were drowning out the rest of the graph. So basically I said if it's over this much, I don't care, it's just high. So again, you can see that These numbers, especially for output, were very reasonable and didn't have any big spikes in there. We had to have one big spike for write latency, sequential out. Block latency. Block latency is the blue line. Sorry, block latency as opposed to rewrite latency. And then random seeks again did pretty well on most of those too. So I can send you guys see the slides. You guys can have the download link. You can take a look at what those are and compare them yourselves. But I was really surprised at how well it performed when I was running my benchmarks. And again, admittedly not a fair test.
Yeah, the same thing. The ranges that we had. Again, yeah, in practice, I think we've seen gigabit connected host be able to saturate its connection to our old cluster writing, and a 10 gig connected host be able to saturate that connection to our new cluster when writing. It's been a little bit slower reads in practice. I think because Ceph still only reads from the primary replica, so there's a little bit more bottleneck there than there is with writes.
We are to the end. Any other questions we didn't answer along the way? Brian, you have anything to add?
No, this has been good. I've been busy taking notes.
Here we go. A couple things. Bioinformatics codes often create a large number of small files. How well does CephFS handle this? Well, nobody does that well. Trust we. Matter of fact, the one issue that we said found a bug in CephFS was a bioinformatics code. When you get into bioinformatics and small files like that, it's really more a matter of, as far as performance-wise, it's a matter of latency rather than bandwidth, and it does not do as well as Lustre or something like that for latency. When it comes to actually saving the genomes, where it's those huge files, it does really well. Next one, which 1.9 terabyte micron SSD was used in the most recently discussed cluster? That'd be yours.
Yeah, that's mine. I'm looking to see if I can pull that up. I'll throw that into the Slack chat.
Okay. And it says, have you used WAL? If so, how much difference did it make? We do use WAL, but we had that built in from the beginning, so I can't give you before and after numbers. Anything to add there, Steve?
No, I think it's just been built in for us too. We haven't made any switches to that.
Okay. Next, for Scratch and HPC, how is performance good enough? Any big complaints from users? It's faster than local disk, I can tell you that. So I have not seen complaints from users. Then again, our users have not typically come from, big systems with well-maintained and really good Scratch systems. So I don't know how valid that is. But like I said, I know it is better than local disk. So our people have been generally pretty pleased with it. Of course, for Scratch, everybody's still looking for more. So how large is the WAL drive? We've been using 10 gigs per OSD. And will slides be posted? You should have a link to that. If it's not already in the Slack channel, I'll put it there. But it's just my own Google Drive slides that I've got there. So I will put, if it's not already there, yeah, okay. Thank you, Alan. Anything else? And for anybody listening along, WAL is write-ahead logs, just FYI.
All right.
Thank you, guys.
Yeah, thanks.
Well, Steve and Kyle, thank you very much for putting together the slides and the information for today. This has been really good.
Happy to do it.
So we will post more information to Slack and mailing list once we kind of have things sorted out for where we'll kind of post this recording, and the other logs that kind of go along with it. So anybody who wants to review it or share it out with others or miss today's can get to it. But we really appreciate everybody's participation. I'll just make a plug. Look at that spreadsheet we have for the topics. Help us keep some ideas for up and coming meetings in there, especially ones that are on topics you're either especially interested in or willing to even present on. But thanks everybody for coming.